This video goes through the concept of LAOS bridgeless minting and evolution, a pattern that enables use cases that are currently impossible in the most mature blockchain ecosystems. LAOS allows any blockchain to scale all transactions for asset minting and evolution, allowing users and developers to remain in Ethereum, Polygon, or their preferred blockchain at massive scale and, more importantly, without bridges. Minted assets remain tradable in Ethereum or the blockchain of choice instantly, allowing users to trade right away without having to bridge or wrap their currencies. LAOS is a full layer 1, a decentralized consensus system secured by Polkadot. It is the first blockchain to leverage universal location, part of version 3 of Polkadot's cross-consensus messaging, a pattern that allows blockchains to refer to specific locations in any consensus system, such as an asset inside a 721 contract inside Ethereum. It all starts with a one-time transaction in the blockchain of your choice, the deployment of a universal ERC 721. It's a standard 721 with a minimal extension that defines a sibling collection in LAOS using universal location. After that one-time deployment, devs and creators can start minting and evolving assets in LAOS, while users see them instantly in Ethereum or Polygon, ready to be enjoyed, utilized, or traded and lent in the vast amount of dApps present in the mature ecosystems. No bridges, no need to wrap coins. Users don't need to change anything to benefit from bridgeless minting. They can keep using their preferred wallets, their already acquired currencies, and their preferred marketplaces. Games, marketplaces, and dApps can simply replace the EVM RPC endpoint they use for that of a universal node, a fully permissionless node that extends the base functionalities of the EVM of choice in a fully retrocompatible way. To dig deeper into the universal node, let's review how dApps normally use the blockchain, using Ethereum as an example. An essential component is to route the dApp queries to an Ethereum node, either via self-hosted or using third-party hosting services. From it, they can get, for example, the tokens that a user of the dApp owns. To actually display those assets, in a game or a marketplace for example, dApps also need to communicate, typically with centralized servers, to fetch the name, description, attributes, images, and so on. Occasionally, this data can be retrieved from decentralized systems like IPFS. Since this approach is inherently static, an alternative is to use a private server solution for nearly all NFTs that are designed to be dynamic. The universal node simplifies this pattern and extends its capabilities. It provides one single EVM RPC entry point to an architecture containing two consensus systems. Let's dig deeper. The universal node contains a standard Ethereum node, either self-hosted or connected to a third-party hosting system. Likewise, it contains, or is connected to, a node from the LAOS Layer 1. Most of the incoming queries and transactions are simply bypassed, routed to the Ethereum node, routing the answer back to the dApp, thus behaving like a standard Ethereum node. The universal node maintains a minimal database, synchronized with both consensus systems, with the essential data required to reply to queries about bridgelessly minted assets. In other words, to fulfill the ERC 721 or 1155 specifications. For example, in order to reply to how many NFTs are owned by a user, it is necessary to read the tokens minted to such a user in LAOS, as well as the tokens potentially sold or acquired in Ethereum. The universal node automates the routing of the queries related to bridgelessly minted assets to the database. From the point of view of the dApps, pointing to a universal Ethereum node without any change in their code directly enables bridgeless minting, maintaining compatibility with everything else they were doing. Behind the scenes, the whole community wins. Using a consensus system instead of a mixture of private servers and static pointers to IPFS provides traceability of the entire history of all assets, including their attributes. It enables the change of such attributes via a true consensus system in a decentralized way. And of course, it allows the offloading of all mints and changes to a layer 1 specialized in these transactions, and with sharding-based scalability in the midterm roadmap.